Aurora is a sophisticated scheduling system that was designed for easy customization. Stadler-Henke has successfully applied it to a number of disparate domains, everything from NASA space station processing preparation, to missile intercept scheduling, to airplane assembly scheduling and shipyard scheduling. Scheduling problems in general are highly variable, and an out-of-the-box scheduling system rarely performs very well. Aurora was designed to help satisfy this lack in general scheduling systems. In this demonstration, I'll first give you a high-level overview of the various objects involved in scheduling. In terms of ways of constraining the schedule, one of the primary ways is through resources. A resource is something that is needed in order to accomplish a given activity. Usually, you only model those resources that could potentially constrain schedules. You wouldn't, for example, model a paperclip. You mainly model large things, expensive things, dry docks, equipment, personnel, things that you can't get more of at the drop of a hat. Resources have a number of characteristics and attributes that influence the way in which they schedule, and you can also group resources into resource sets. Now, various resources have a huge number of attributes that indicate when they could be used for what purpose. It's not always practical to model all of those attributes, and so resource sets give the user a very easy way to define which resources are interchangeable in a given context. In this particular example, you have large dry docks, which are made up of all the large dry docks, or you also have a large dry dock with crane set, which only includes two of the large dry docks. Now, I could have done this by adding a dry dock attribute to all dry dock, a crane attribute to all dry docks. However, that would involve a very specific attribute for which I would have to add some logic on the back end indicating how it should be used. Instead, the user can simply define two resource sets indicating that in one context, with an activity that needs both a large dry dock with crane, these two are interchangeable, and that in another context, with an activity that only needs a large dry dock, these three are interchangeable. This gives the user a tremendous amount of flexibility without having to meddle with back-end logic. Activities, as I mentioned before, are the atomic unit involved in scheduling. Now, these activities here are basically templates for the activities that are actually defined as part of the compound activity in the scheduling problem. The reason you may want to define these here is, first, they can derive off of each other. So if you have a standard type of activity, you can define some of its resources in a single place. And the other reason you may want to define activities here is so that you can reuse them over and over again. For example, pre-work inspection will be used with almost any sort of shipyard task. Finally, you have calendars. Now, in this particularly simple example, I don't have any calendars defined. However, if I slip over just for a moment to the much more complex example that I'll be addressing later, we do have a calendar. Calendars define when various things can happen. So this particular calendar, calendar 1, basically defines a standard factory shifting structure. Now, here it's defined as 7 days a week. Normally, it would actually be defined as 5 days a week. You can see how this display updates to indicate when I can do what work. So the calendar basically indicates when things can happen. Calendars can be identified with activities, which basically indicates that that specific activity has a limited window of opportunity. They can be defined with resources, primarily in conjunction with personnel resources, although sometimes with equipment resources as well, or they can be defined in association with the compound task itself. And that would indicate that overall there is sort of a standard project schedule, if you will. Those three calendar sources are cross-referenced in the scheduling process to make sure that things only schedule when the full calendar indicates they can. In terms of associating resources with activities, all activities have this resource requirement subtab, and that allows you to add one or more requirements. You can either require a specific resource directly if you know exactly which one you want, or more commonly you would request one element or multiple elements out of a resource set. You can also associate different atomic activities with each other using constraints. So in this particular case, pre-work inspection has two successors, these two elements. And I can gain more detailed information about the constraint by looking at this. In this particular case, it's a finish equal start, which means that the shipyard processing has to start as soon as pre-work inspection is finished. A more common sort of constraint is finish less than or equal to start, which is a standard predecessor constraint. It basically means that once pre-work inspection is done, at some time after that I can start the large equipment installation. That covers the basic types within Aurora. I'm now going to run the demo involving this smaller sample file. That's going to be in another recording, and that will be followed by a third recording that will cover the scheduling of this much, much larger scheduling problem. Thank you for your time.